Hello, everybody. Can you hear me? Please let us know in the chat so I'm not talking to mute. Okay. Um, Welcome to the very first AWS Community Pre-Event Warmup 2025. Hopefully, you don't have to get up too early. Please let us know in the chat what time it is in your area, so we can feel a little sorry for you. Okay, let's get started. At the beginning, there was a group of eight enthusiasts all around the world sharing a same dream of creating this online event that would be visible for everyone and with cool price. So those eight characters represents each of us. And just for your information, I'm not the bearded guy behind the computer. I'm the Sub-Zero on the right side. That's pretty obvious, right? Okay. So let me introduce you to our crew. We got Lydia from user group Košice in Slovakia. We got Anna from Women user group Colombia. Joanne from user group Orlando. Bansi from user group Toronto. Thorsten from user group Stuttgart in Germany. Ricardo from user group Buenos Aires, Argentina. Shaoi from user group China. And my name is Michal. I lead user group Košice in Slovakia along with Lydia. Lydia is in studio with me. Okay, yeah, we've been practicing that for like last hour. Um, but the crew were not the only ones helping us. We got also a lot of user groups from all around the world that were supporting us, and it is my honor to tell you a little bit about them. So I'm very happy that actually we also got three ladies user groups. We got women user group from Colombia, women's user group Sweden, and girls user group Uruguay. And then, as you can see, a lot of user groups from all around the world: France, India, Italy. Probably most, if not all, of the user groups from India joined this event. So a little clap for them. Thank you so much. And now, again, as you can see, Germany, Turkey, a lot of user groups from really all around the world. I would say from Sweden to Balkans, from China to Colombia. This is great. User groups were not the only ones supporting us. Also, the communities or community days were supporting us, like Community Day Adria. They just hosted very successful community day 4 days ago. 500 people, Jeff Barr doing a keynote. This is great. Also, Community Nordics, which is Scandinavian user groups community day. They will host their community day on October 10th in Gothenburg, Sweden. Community CEE, which stands for Central and Eastern Europe. This is user groups all around from Vienna to Greece and from Slovakia to Romania. A lot of user groups doing this joint operation of Community Day. They will host it on October 16th in Budapest, Hungary. Also, Community United Arab Emirates. They will do their Community Day on October 19 in Dubai. And our Community Day from Slovakia, we hosted our first CD on March 2025, and we'll have another one on March 2026. All those user groups and all those community days are on our page. If you feel like joining any of those, just go to our page, click on the logo. It will lead you to the meetup link, and you can join. They will be more than happy. And I have to tell this, none of that would happen without AWS, of course, and without two great Amazonians, Maria Encinar and Viktor Vetmic. Can you hear us now? Okay, so I guess we are back online. Please let us know if you can hear us and see us. Sorry for that, there was some transmission issues. Okay, so again, all the times are in CEST, which stands for Central European Standard Time or Summertime, I never know. Important is that's UTC +2. So please get some time zone converter or something like that, just not to miss any important presentation. Then from 10:15 to 1:45, we'll have a block of presentations. That's 6 presentations with 5 minutes break after each, so we can have some quick refreshment. And all the agenda can be seen on our page, awscommunity-global/agenda. Then at 1:45, we'll do, actually Lydia will do short demonstration on how to join the raffle. And by the way, if you see somebody responding on the chat to you, that's Lydia. She's doing that all day. Yeah. Okay. So again, 1:45 short demonstration on how to join the raffle because you need a couple of things to be eligible to join the raffle. And then at 2 p.m. approximately, we will open the raffle registration. And you will know that the registration is opened because this button will appear. So as soon that button appears, you can start registering. Maybe it's going to be 158, we don't know. So if you see the button, you are free to register for the raffle. What is the price today? So the price is AWS reInvent experience. That's AWS reInvent conference in Las Vegas happening on December 1 to December 5. And flight, hotel, and a ticket all covered by AWS and for 3 participants. You need 2 things, actually, more than 2 things. So you need AWS Builder ID, and you need 6 keywords that are displayed during each presentation. And it may look something like this. You see keyword and then quotes and the keywords in the quotes. So as soon as you see that, write it down or memorize it because you'll need it at the end during the registration. And yes, and the winners then winners will be announced on our web. So then you will see this button when the winners are announced, probably around 6 p.m. UTC +2. So around 3-ish hours after the event ends, you click the button and you see the winners. Winners then will be contacted by email, and also the agency that AWS is working for will contact them for all the details. And now let me introduce you our speakers, because they actually are doing this event. So we got Daria from Poland, we got Hazel from Guatemala, we got Harini and Kiran from India, Jimmy from Sweden, Miguel Angel from Spain, and Luis from Peru. Ladies and gentlemen, once more, welcome to AWS Community Pre-Event Warmup. In the name of all crew and all user groups, it is my honor to greet you here. Anything to add? Okay. Okay. Yes, Lydia just having a lovely conversation in the chat. Now let's have a short break. Before we do that, the QR code that you see, the same QR code will be displayed after every single session, and this is the Q&A. So as soon as we have any questions about what you saw in the presentation, just scan the QR code. It will lead you to the Google Docs, to the Google Forms. You can choose the presentation, type your question. We will then send it to the presenters, and they will answer you by email as per day, their time availability. Okay, so we have 4 minutes until first presentation starts. So let's grab a coffee, some snack, some tea, and let's for the first presentation. That's gonna be Harini and Kiran. Thank you.
Hey everyone, I hope you guys can hear us.
Yeah, please let us know if you are able to hear us.
Yep,
Yeah.
awesome. Thanks for the confirmation. So, hey everyone, thanks for joining from different parts of the world today. In today's session, we'll explore how to take AI from simple concepts and experiments to production ready enterprise grade applications using the AWS Agentic AI stack with Kiro, Strands, and Marketplace Agent. I'm Harini Muralidharan, Senior Delivery Manager at Presidio and an active AWS community speaker.
Hi, myself Kiran Ravichandran, Lead Engineer at Presidio, AWS Community Builder in Machine Learning. So together we have been building cloud-native AI-driven solutions, and today we are excited to share our learnings.
Cool. So, kickstarting the presentation, we just wanted to give you a picture of how enterprise are thinking nowadays. And the enterprise everywhere are embracing AI, but most are still stuck in the experimental phase that includes proof of concepts, prompt testing, and API trials. So the real challenge begins with that when we try to take those experiments into production, moving from a demo to a secure, scalable, business critical application that requires a new approach. The primary challenge of traditional development aren't built to handle these inputs as the challenges. So that includes complexity of converting business use case as required for the development, scalability to handle large requests, maintaining constant oversight and security, and finally, time to release into large scale production from development and from POC. Moving on, so we are seeing a fundamental shift in how enterprises are thinking about AI, moving from model as an API to agentic systems. So, model as an API, which is good for experimentation but limited by simple prompts and narrow context. We are now shifting the thinking towards agentic system, and these systems are goal-oriented, context-aware, and capable of handling multi-step workflows, making them ready for enterprise scale. This AWS Agentic AI stack is designed to tackle the challenges that traditional workflows can't, the challenges that we just explained in the previous slide. And this new paradigm reduces the complexity of breaking down multi-level business use cases into intelligent workflow automations using agents and tools. And when you see, when it comes to model as an API, it usually is client or a server integrating with a similar thing like Bedrock as an API with prompts and inputs as such. But when it comes to agentic system, it involves multiple components for us to architect and modify as we need, starting from having a serverless architecture with Lambda as a trans agent. That is what we are going to walk through down the presentation. And that can be integrated across multiple sources, which can be a marketplace, which can be even Bedrock, and internal AWS services, and even web APIs and external third-party integrations. This is the architecture that we are targeting for to provide that flexibility for the agentic system that would help us grow towards the production scalability approach that we are looking for. Moving on, so let's briefly introduce the stars of our show. I think you would have already seen in the title that we shared. The first is AWS Trans Agents. It's an open source SDK, and this is the heart of our agent logic. And it's a model-agnostic framework that simplifies the process of building autonomous, goal-oriented agent using a flexible, prompt-driven approach. And next, we have Kiro, an AI-native IDE. Think of it as your co-pilot for the entire development lifecycle from ideation to production-ready code. And finally, the AWS Marketplace for Agents. This is your toolkit. It's a curated catalog for third-party agents and tools that you can easily discover, procure, pay as you use, and integrate into your application, all with the security and governance of AWS. When you combine these three together, you get a powerful end-to-end workflow. We will now explain all of these three individually and walk you all through integration of these with an example case study and real-time action as a demo. Now, first let's dive into Strands. So the Strands is the framework. It's an open source SDK that provides the fundamental building blocks for your agent's intelligence. Strands is designed around a model-first approach. Instead of writing complex if, then, else logic, you empower the LLM to reason and orchestrate the workflow based on your prompts and the tools you provide. So you ideally shift the complexity from code and giving that responsibility to LLM. So this is what enables the autonomous goal-oriented behavior that we were discussing so far. And at its heart of the Strands is this agentic loop you see in the screen. It's a continuous cycle of reasoning, planning, acting, and reflecting. So reasoning is the initial step where user prompts are processed. And with that provided input, the spec and all the details are being generated and formulated a plan. And it formulates a plan of action based on the plan that we have created, it act on code changes or any functional call changes, tool integration, and finally it reflect on generated code to iterate till the goal is met. So this is how Strands agent can break down a complex user request into a series of smaller executable steps and corrects itself if something goes wrong. This dynamic flexibility is what makes it so powerful for multi-step task. The key benefits of this, so faster iteration, you get greater adaptability, you also get lower maintenance and seamless scalability. So this is the detailed explanation of Strands agent, and let's move on to the next core pillar that we have for the session. That would be Kiro. If Strands is a framework, Kiro is an IDE that incorporates it. So usually a common disconnect or frustration is when we convert high-level idea we have for an agent with and the nitty-gritty detail of writing production-ready code. So connecting that would always take some efforts and time. And Kiro addresses this heads-on. It gives you two main ways to build it. So you can see in the screenshot if you have already haven't visited Kiro or used it before, you can see the screenshot. It provides two options. The first one is vibe driven. It is perfect for quick experiments and getting a feel for an idea. You give Kiro a high level concept and it generates a basic working agent in minutes. And the second one, that is the highlight of our demo as well. So the spec driven. This is more rigorous approach for production ready applications. Instead of just generating code from a prompt, Kiro first helps you define a detailed structure plan. This plan becomes a machine readable spec file that acts as a blueprint. So now the spec file with the spec driven approach, this is a game changer because it allows you to get an explicit agreement with the AI on what it's going to build. It's not just magic, it is a reproducible, auditable, and testable workflow. And Kiro can then use the specs to write the code and even generate test cases, generate documentation, and other artifacts automatically using hooks you define. And you can see the Kiro workflow mentioned here. So when you, it includes first with ideation step, where you ideate using natural language prompts. Then you generate AI, then the AI generates spec files for you to validate. Then build code from the spec based on your confirmation. And then finally automate the process of adding tests and hooks and all the aspects. So this is the high level workflow of how Kiro works and what is the problem and the solution that we are trying to focus with Kiro in the picture. And coming to our third and final pillar, so this is the AWS marketplace for agents. And your agent is as good as the tool it can use. So building every single tool from scratch is time consuming and inefficient. That's where marketplace comes in. The marketplace provides a trusted, curated ecosystem of pre-built tools and solutions. You can find everything from a web search tool to a CRM integration, all ready to be deployed. You can just plug in, identify the tools that you want, integrate it with the workflows, and even extend it to Bedrock or Strands as tools and functions. And by doing this, the key benefit here is that you get to leverage solutions that are already vetted and integrated with AWS security and governance. And crucially, these tools are built on open protocols like MCP and A2A, which means they can communicate with your Strands agents or even with other agents, creating a much larger, much powerful system. So here's few example. You can integrate Stripe agent for transactions and payment related tool, and you can use Datadog or Grafana for observability and marketing, or even something out of here. So Unpayable, that is a translation tool, real-time translation tool that you can use from Marketplace. And leveraging Marketplace is just a simple process. You just have to discover it. You have to integrate that. You can pay as you use and benefit out of it. And now with integrating all these and with these three key pillars, you have added a powerful functionality without writing everything from scratch for your to be production ready application. So that covers the pillars that we are covering for this session. So I'm giving it over to Kiran for explaining this in use case and a demo in detail. Over to you, Kiran.
Yeah, thank you, Harini. So now let's put it all together with a quick high-level example. Imagine you want to build an advanced customer service agent for an e-commerce platform. Usually, we need to write manually to define every possible workflows, create and hardcode APIs for main functionalities like order lookup, return service, FAQ service, etc. And for each and every edge case, the common challenges are like complex workflows, longer development time, and rigid, unscalable system, right? So it is also difficult to scale human agents when business grows, as it is expensive and to take more iterations. Even when the workflow is implemented successfully, there seems to be workflow issues, including long waits, inconsistent user experience, etc. So it's obviously clear that we need smarter solution. So the the difference between the traditional and the new way is like here we start with Kiro, and we could just prompt it something like build an agent for order tracking and returns. So Kiro helps refine the idea into a detailed specification with user stories, such as customer being able to check their order status with their ID. Instead of writing custom API wrappers, you find pre-built tools on the AWS marketplace for agents such as tool for payment, logging, and multilingual support. Kiro then scaffolds the Strands agents to handle the conversation and decide which tool to use. You deploy the agent to serverless environment on AWS using Strands, built-in observability and scalability to handle thousands of concurrent requests. So now that we have the entire cycle, maybe let's move on to the demo. So here I have a video recording since I will be showcasing the entire workflow on like how to build how did I build an application from scratch. Yeah, let's get started. So here within Kiro, under the specification, I just gave a prompt stating that I need a customer handling service for an e-commerce application. And we could see it started to create a document file called requirement.md file, where it is going to create all the necessary requirement for this particular use case. So here the requirement is generated, and we could see like it has a detailed description on like what are the different packages it is going to use, what are the different tables it is going to create, and what are the different APIs that is needed in order to create this application, folder structuring. So here we have a detailed requirement that is given. So additionally, I'm going to ask further more technical details so that few things like monitoring and the security related items were missing. So when I ask it, I could see like it added additional requirements such as system integration, security compliance, and analysis and data management, etc. So once the requirement is complete, the next phase is the design phase. So we could see like it started to create something called design.md, where all the architecture related items will be created here. So like what kind of architecture design pattern the application is going to get generated, something like the event-driven architecture, or what kind of APIs, or what are the different the third-party integrations that we are going to make. So on a high level, it is going to give us from the scratch till making onto a production level application.
So I see the comments that you guys can't hear us. Okay.
Okay, I think now it is fine. Okay.
So we will rewind just to make sure that we are caught up.
Yeah. So yeah, so totally within Kiro, we have three different things. Like one is the requirement phase. So once the requirement is complete, it is going to start with the design plan. And in design is going to give us architecture overview on like how the application is going to build, like what are the different architecture pattern that it is going to follow. And all of those details will be given in the design.md. And next comes task.md, where it is going to give us what are the different set of tasks that is needed in order to build this application. So once we went through all the tasks, and if everything is looking good, we could click on the finalize task list button that is showcased there in the Kiro. So once we click on that, the next thing is to implement all of these tasks. So we could just accept we could just review and we could accept all the different tasks that it has generated. And so once it is accepted, we could go ahead and tell like, now can you implement all of these tasks one by one in order to build this application. So once we do that, it is going to process each and every task one by one, and it is going to build the entire application for us. So that's the power of Cairo. And here we have an option to pass the file name as well. So giving a hashtag symbol is going to populate a tooltip where we could select what file we need to pass. So in my case, I had all the tasks in task.md, and I'm just passing that particular file. So once I pass that, it has started to create the necessary application code that is based on the task that is that it has picked. And we also have an option there on the top called task list, where we could see like what are the different tasks it is going to process and what is the current task that is going on. So while it is processing, there could be certain CLI commands that it has to execute. So during which Kiro is going to prompt us like, can I execute this particular CLI command or not? So there could be certain human interaction in the mid as well. And now we could see like it has started to create the code for the front end and the back end. So in this case, the backend code is written in Python, and for the front end, it is generated using Angular. And with respect to backend, since we went with Python, right? So we are making use of AWS Strands in order to orchestrate the entire SDK. Here, instead of writing independent APIs, AWS Strands is going to be the key or the heart of this particular application, where it is going to get the user question, and then based on the user query, it is going to process it. And here we could see it is going to use a concept called Swarm. So Swarm is a collaborative agent orchestration system where multiple agents work together as a team to solve complex tasks. So Swarm enables coordination between agents and shared context and working memory as well. So we also have monitoring service to track all the metrics. And here we are passing different agents like customer service agent, order processing agent, technical support agent, fraud analysis agent. Like these are some of the different agents where we are passing it into Swarm. And we also have certain options on to control how is the handoff going to happen between the agents. So all of those things. And we also have the task routing system where we could add from which agent to which agent how the the information has to travel. And we also have the process task function where all of these information are getting processed. And we also have the monitoring service to track what is happening in each and every agent inside it. So this is going to give us a detailed overview on what is the latency for each and every task. So how the agent is getting processed, all of those things. And this entire application is built using serverless framework. And we have an option called serverless deploy, where we'll be able to deploy the entire application using the particular command. So once it is deployed, it is going to create a CloudFormation stack. So which looks something like this. So it is going to create all the necessary AWS resources that is needed for us. And we are making use of DynamoDB to track all the different tables that we have. So starting from agent state, chat orders, ticket status, and the user. So this is going to manage. And this was the beautiful UI that was generated. And here we could see for each and every ticket, we have a detailed user action, the ticket description, and others. And we also have a chat option to to interact with the user. And we also have the order management system. So this particular page is to showcase like what are the different tickets that we had and what is the priority for each and every ticket. And when it comes to orders, so here are the different orders that is getting placed, and we have different status for each and every orders as well. And this is the dashboard that showcases the annual revenue and the revenue breakdown per quarter, and showcasing some of the performing products which is there in the e-commerce website. So that's the overall overview on the application. And we also have the Grafana that is integrated from AWS Marketplace, where we could see like what are the different open tickets that we have and the performance metrics for each and every agent in real time. And we could also see the agent responses, like how much delay or the latency that it takes for each and every agent. And we also have a complete dashboard to visualize like what are the different active chats that is there, and what is the response time for each and every chat, how many users are there online. So this could actually showcase more of the analytics and the monitoring part of it, which actually makes the application to be production ready. So over to the overall architecture. So with the code generated, let's look under the hood at the architecture. Our Strand agents sits at the center, powered by large language model like Claude 3.5 or on Amazon Bedrock. The agent doesn't know how to do anything on its own. Its power comes from tools we give it. In this case, we have a custom tool for our internal customer data and two tools from the marketplace. One is our CRM and the other one for the web search API. We also have a tool for sending email. Strands is going to handle all the orchestration. It decides when to call each tool, what parameters to pass, and how to use results to progress towards the final goal. The LLM reasoning capability is guided by our prompt, and tool definition is what makes it all work. This is what the production-ready solution looks like. It is more just than a model and a script. Our users request comes in through the API gateway, which triggers a serverless Lambda function. This function hosts our Strands agent. The agent, in turn, interacts with Amazon Bedrock for its reasoning, called tools from Marketplace, and connects to the internal microservices. Crucially, we have an observability built in. Every step, every tool call, every decision, and the agent makes logged into the CloudWatch and X-Ray. This provides the transparency, auditing, and debugging capabilities that are absolutely essential for enterprise application. This architecture is a blueprint that you can adopt for most of the agentic use case, from automating internal workflows to building external facing conversational assistant. So I'm handing over to Harini to talk on why is this approach enterprise ready.
Yeah. Thank you for that great presentation and demo, Kiran. So you guys would have seen it real time of how the integration of Kiro, Strands, and the marketplace works. I know this was a recorded video demonstration because of the time limitations and restriction of what we had to show. But please do reach out after this session, and we will try to share the code as well. But this is just to provide you on high level of how three phases of the planning, designing, and the task list work with Kiro. And you can see the output of that application. All the colorings, all the entire website was completely generated by Kiro itself. And we did not provide any UX as input. We did not provide any color codes or any inputs apart from the prompt that we showcased. Those are the just inputs, and you can see a fantastic output that was received out of that Kiro. And with that, so why we feel this approach is enterprise ready is this combination of tools give you a complete solution for building agents that are ready for production, not just for a demo. And primary reasons are, first is security. You can manage permissions and access for every tool call. The third-party tools from the marketplace are vetted, and you saw the real world implementation of the monitoring integration with Grafana as well. That gave you an overview of all the access, all the invocation that tools made. And the second one is scalability. The architecture that we discussed is built on AWS Lambda, which is serverless. It scales automatically to meet demand, so you can handle a single onboarding request to or 1 million even. And the next one is governance. So the specs from Kiro and the observability from CloudWatch ensure you have full control and visibility into your agent's behavior. So this is crucial for compliance and auditing purposes. And finally, the key reason is the developer productivity. As a developer, you get to focus on what matters. That is the business use case, the business problem, while the tool can handle the boilerplate and the complex orchestration logic that you wanted to handle it for the production ready application. So this is the reasons why we feel this approach is enterprise ready. So with that, we have covered the three key pillars. And finally, a call for action. So the agentic era is here. It is not coming, it is already here. And the tools to build are more powerful than ever. So we encourage you all to get started. Check out the open source Trans Agents SDK on GitHub. It's a great way to start experimenting with agentic logic. And explore the Kiro IDE. The waitlist is open, and you can download and log in with the access code that is provided based on your waitlist. And it's a phenomenal way to transform your development workflows. You have to try it out in real time for sure. And finally, when it comes to AWS Marketplace, browse the marketplace for agents to see what's available. You might find a tool that can accelerate your next project by months. So you can definitely check that out.
And thank you for your time and attention. I hope this session gave you a clear picture on how enterprise can move from AI experimentation to production-ready systems using AWS Agentic AI stack. Let's connect and keep the conversation going. Here are our LinkedIn profile, and please feel free to send us an invite. Yeah.
Yep. Thanks for listening, guys. So we are happy to clarify any questions based on the forms and even through LinkedIn as required. Thank you for joining today.
Thank you.
Thank you.
Hi everyone, welcome to the presentation. Hi everyone. I am excited to be here, and today my session is how to do RAG without breaking the bank, how to create cost-effective vector storage. Let's dive in. I wanted to start with a quote said by Swami, who is VP of AWS Agentic AI. During the recent AWS summit in New York, he said, "Vectors are the language of AI." And if we think about it deeply, we reflect that AI is as intelligent as the underlying data is. So no data, no intelligence. And because the information amount grows and grows over the years, and there are a lot of, like in memory conversations, some chat histories, the amount of vectors that should be stored, the amount of data that should be stored goes from millions to billions. And with that, there is no just temporary storage for vector storage. This is a strategic asset. So today we're going to look into what is S3 vectors, how to create S3 vector index from scratch, and then how to create a Bedrock knowledge base powered by S3 vectors. And then we will see how to build with this knowledge base a Bedrock agent. And then we will see how to use different strategies and smart tips how to increase the accuracy of our solution, of our application. My name is Daria, and I'm AWS Community Builder since 2022. I work as a senior data scientist at SLP. And in general, I like knowledge sharing. I like to learn and share my knowledge. Let's dive into Amazon S3 vectors. So what is S3 vectors in a nutshell? It's the first cloud object store with native vector support that delivers cost-optimized storage and sub-second query performance at S3 scale. And it goes up to 90% lower in cost. So it makes practical to manage billions of vectors with elasticity and durability of Amazon S3. So kind of very interesting solution. And how it works. It's all start from the documents, from the original documents. They should be split into parts, chunked in other way. And we should use an embedding model that will convert this textual data into vector data, essentially numerical data. And then we can store those vectors into S3 vector bucket. It's a new bucket type with APIs to store, access, and query vectors without managing infrastructure. The data will be organized into vector indices, which there could be up to 10,000 vector indices per bucket. Each vector index can hold up to 10 of millions of vectors. And this whole thing is automatically optimized as you update your data, update your vectors, and enables us to do semantic search via vector index at scale. So when I went through the concept, I understood that there could be some potential misunderstanding of terminology. So let me break it up for you. So first, like the biggest, the highest level of storage here is a vector bucket. It's a new bucket type that is purpose-built to store and query vectors. And inside vector buckets live vector indices. You organize your vector data within those indices, and you perform similarity query on your vector data with vector indices. And each vector index includes vectors. For AI and similarity search, these vectors are created as embeddings. So let's say this is a numerical representation that captures semantic meaning of text. this, you think text, but the original data can be any format. It can be text, audio, video, images. Because it's semantic, we no longer need to search using the exact match. This enables searching by meaning, and each vector can also include metadata, and we'll be talking about metadata later on. What is nice that S3 vectors also integrated natively with a number of AWS services. You can see here Bedrock with knowledge bases. We will be looking into this solution, and also SageMaker Unified Studio. You can use them to create RAG-powered applications. Which is also nice, it is integrated with Amazon OpenSearch Service, and you can tie vectors. You can store those vectors that are for historical storage and doesn't require a low latency, high performance workloads into S3 vectors. And you can store those that are frequently accessed in Amazon OpenSearch Service, keeping the cost down. Yeah, I mentioned cost effectiveness several times. Let's see, is it really that cost effective? Previously, one of the most popular options to store vector indices on AWS was to use Amazon OpenSearch Serverless. And you can see by the table, let me bring your attention, that the cost structure is different. OpenSearch Serverless charges based on the OCU. This is a compute unit that bundle CPU, memory, and storage. And the minimum cost, you need to use minimum 1 or 2 OCU. And the minimum cost would be starting from $174 per month, easily going up to $350 per month. Even if you don't query your vectors at all. Yeah, but with Amazon S3 vectors, there is no baseline payment as such. You pay only for what you are using. And you can see that cost is really, really down. You pay 6 cents per gigabyte per month per storage. For put, you pay 20 cents per gigabyte. For queries, it's just a fraction of cent per 1,000 queries, and a small data processing fee when you query your data. So if your workloads don't require constant real-time vector search, S3 vectors is definitely an interesting option to consider. Now let's see how to create an S3 vector index from scratch. If you're using AWS Management Console, you need to go to Amazon S3 console, and the left navigation pane, select vector buckets and choose create vector bucket. Then you need to enter your bucket name and choose an encryption type. If you don't choose an encryption type, Amazon will apply S3 managed key as a base level of encryption for new vectors. Once your vector bucket is created, you can create a vector index to store and query your vector data. To create a vector index, it's also a very easy process. You enter vector index name, and then you enter the dimensionality of the vectors. And put attention here that all vectors you will be inserting into this vector index should have the same dimensionality. For distance metric, you can use either cosine or Euclidean. I would say this depends on the embedding model you will be using. And once you choose create vector index, and you can insert list and query vectors. You can see that this is created, but in order to insert list and query vectors, you need to use AWS Command Line Interface, CLI, or AWS SDK, or Amazon S3 REST APIs. Yeah, let me show you a quick example how to do this. This is using the latest AWS Python SDK. And you can generate vector embeddings for your text using Amazon Bedrock. This is a code example. So here, I have a bunch of tasks. They are all related to AWS programs, AWS Community Builders and AWS Cloud Club Captains program. And I'm using Amazon Titan embedding version 2 model to generate embeddings of these pieces of text. And then after the text was converted into vectors, I need to insert this vector embeddings into my vector index. So I have the vector bucket name here. I have my index, vector index name here. And I see here, I'm adding metadata for each vector. I'm adding ID, I'm adding source text, and I'm adding the mark of the program, which is community builders for some of them, and which is Cloud Club Captains for others. So you will see how we use this metadata when we query our data. And then I have a simple query. I have a simple question. What are the program benefits? And you can see this is a program agnostic question. Yeah, I can ask this question no matter the program is. And but before asking this question, I need to embed it, convert it into vector using the same model that I used for my vector embeddings. This is Titan Text Embeddings version 2 model. I converted my query. I'm using my query to query the data. I need to have at least top 3 vectors returned. And I will use metadata filtering. First, I want to know what are the benefits for Cloud Club Captains. And the second example would be about community builders. So let me show you a simple demo. This is the code you essentially saw in my slides. I converted my text into embeddings. I inserted them into vector. And I'm asking the same question about benefits for Cloud Clubs and about benefits for community builders. And if I run my code, this simply will return me some vectors. There is no concise answer because I'm just trying to retrieve the relevant pieces. As you can see, for the first question about Cloud Club Captains, I have program Cloud Club mentioned in the metadata. And for the second program, I have community builders mentioned in the metadata. So this is right. Let's go back to the presentation. For those of you who like to use different command line interface tools, there is S3 Vectors Embed command line interface, and you can use it to create and ingest vector embeddings into S3 vector index, and also to query, all using a single line comments. Document chunking is not currently supported, but I think this is a promising tool to at least experiment. And now let's see how to create a Bedrock knowledge base with S3 vectors. The creation process of knowledge base is simple. We go to Amazon Bedrock console, we choose Builder Tools, Knowledge Bases from the navigation pane, and then create knowledge base with vector store. You need to provide basic details about your knowledge base, what its name, what a permission, and what data source you will be using. In our case, it's Amazon S3. And then you need to configure your data source, specify its name, location. In our case, it's S3. I need to provide S3 URI, and then parsing and a chunking strategy. And we will talk about those strategies in the last section of the presentation. Then you need to specify the embedding model and a vector store. In our case, it's Amazon S3 vectors. And then you need to just review and create the knowledge base. Don't forget to synchronize your data sources so the underlying information is up to date and available for you. And then when you're testing your knowledge base, you have basically the option options. You may want to have the retrieval only. So based on your query, only the pieces of original text will be returned to you. Or you can opt for retrieval and response. So you have the coherent answer based on the context. And also, depending on your use case, you want to change the number of source chunks to be returned to you. You can see the example. I was testing my knowledge base. I asked the question, and there are 5 examples of pieces of original text returned to me, and I can easily trace the original document where they were found in. Yeah, and my use case, I was trying to build a smart research assistant. So I collected different research papers about Agentic AI, A2IA protocol, GraphRag, and MCP, and just dumped them into a S3 bucket. Now, as we saw that this is simple and quick way to create a Bedrock knowledge base, let's use it to create a Bedrock agent. Our Bedrock agent will have a super simple architecture. We have one connected knowledge base. The vector storage would be inside S3 vectors, and it will connect to S3 bucket for original unstructured data. How to create the agent? Again, we have Amazon Bedrock console. We choose Builder Tools, Agents from the navigation pane, and click Create Agent. We need to specify the name and click Create. And then you need to select the model. You want to be the model as a reasoning engine for your Bedrock agent. You need to specify some instructions. Even though your agent would skip the instructions, you would need to specify them, otherwise it wouldn't work. And then inside Agent Builder, your agent constructor, go to the section Knowledge Bases and add the knowledge base. Search for the knowledge base we created in the previous section, add it, save it, and then don't forget to prepare the agent in order to test it. And then you can already test your agent by asking some questions. In this example, I ask, a complicated question, how to build a basic reasoning agent. And you can see that there is a long answer. And I can trace from where agent takes the information. And inside the trace, I can see that it is going indeed to the knowledge base and retrieving the related pieces of information. So moving to the last section on how to increase the accuracy, because you saw an example how to build a plain vanilla Bedrock agent, plain vanilla Bedrock knowledge base, but how to actually increase the accuracy of your application. We will dive into some parsing, chunking, and metadata filtering strategies. So when you are creating a Bedrock knowledge base and when you are specifying options for data sources, you have different options of parsing strategies. In the previous example, I used the Amazon Bedrock default parser, which is going by default, and there is no additional cost to use it. But there are also 2 other options, which is Bedrock Data Automation and Foundation Model as a parser. And let's look whether they worth the additional cost. The difference between them, the first key difference is whether you want to have to provide additional prompt for your data parsing. If you don't want to provide any additional prompting, you just want to simply upload your documents, images, audio, video, and have a structured output, you may want to go with Bedrock Data Automation. And the cost will be on a number of pages in your document, on a number of images, or for the slice of time for audio, video processing. And the cost is pretty affordable, 1 cent per page for North Virginia, for example. Yeah. But if you want to have more flexibility, you can customize the default prompt to fine-tune how the data is parsed and extracted using foundation models as a parser. And the cost in that case will depend on the number of input and output tokens processed by the foundation model. So I would say it may be a little bit unpredictable because it will depend on your document size and your prompt complexity. And very important note here, if you choose Amazon Bedrock Data Automation or foundation model as a parser, this method that you choose will be used to parse all PDF files in your data source, even if they contain purely textual information. So if you have tens of thousands of PDFs pages, that may come as an unexpected cost. But let's see whether it's worth it potentially to choose Bedrock, for example, Bedrock Data Automation as a parser. So you can see the page of my original paper, and there are some pictures. And one picture drew my attention. This is a number of publications of graph racks mentioned in different domains. And there are some information about the popularity based on the domain. So if I use a default parser, it will just skip all graphical information. It will just analyze, just parse the text and use it in your knowledge base. And no surprise, I have no answer. I have a question. How many publications of graph racks is in the knowledge domain? And I have no answer because this image was skipped. But if I decide to use Bedrock Data Automation, I will have an answer that there are 48 publications of graph racks in the knowledge domain. And this is accurate. And how do I know it, that it didn't just make up an answer? If I go to trace the underlying pieces of retrieved information, I will see that there is a nice description of this picture. I can see that different domains mentioned here and a number of publications are also mentioned here. So I just have out of the box clear, concise picture description. So in a nutshell, how to decide? First question you need to ask, whether your data is purely textual. Then you may want to use Bedrock default parser. But if it contains multimodal data, whether Bedrock Data Automation, whether foundation model would be your option. If you want to customize the prompt, then maybe it's foundation model. If you don't, Bedrock Data Automation. Per page pricing is for Bedrock Data Automation, token-based pricing for foundation models. And foundation models also have a limitation. They cannot process files larger than 100 megabytes. And Bedrock Data Automation doesn't have that limitation. The next important strategy is to think about your chunking. If you think about the quality of your embeddings, it will depend on the way you chunk or split up your document. There is a default chunking for approximately 300 tokens, which will respect sentence boundaries. But there are also other use cases like fixed size chunking, when you can specify your custom number of tokens plus specify overlap. Useful when you want predictable chunk sizes. There is no chunking option when the entire document is treated as a single chunk. Best if you pre-split documents by yourself. And there is also hierarchical chunking that will organize your data into parent and child chunks. So retrieval will start with a fine-grained child chunks, but it will return broader parent chunks for more context. And last but not least, semantic chunking. It will use NLP, natural language processing, to split text based on the meaning. And you can tune parameters like maximum number of tokens, buffer size, and a breakpoint threshold. And there are also some associated additional costs because foundation model will be used in this example. Next, you already saw an example how I used metadata filtering for retrieval program-related information. I also wanted to pay your attention that there is a filterable metadata and non-filterable metadata. So that was example of a filterable metadata, where you can attach these key value pairs to your vectors to use them as parameters during your queries. So for example, you can query it by year or associated author or genre or anything you can imagine. And the type could be string, number, boolean, or list. And you can combine using logical operations, different conditions to fine-tune your searching strategy. But there is also non-filterable metadata. It is not searchable, but can store larger context, like full text or image description, and it will be returned with a query result. So it's like a tracing tool. And one more example, I wanted to show you that there are possible multiple conditions on the same field. Like here, you can filter by price, equal or greater than 10, but less than or equal to 50. So anything you can imagine, use your strategy to do metadata filtering. Yeah, S3 vectors are still in preview. So this is an important consideration. You can experiment it with them at this point, but wait until bringing them into production. Currently, there are 5, they are available in 5 AWS regions, and there are certain limitations on the number of vector buckets per region, vector indices per bucket, vectors per indices, and metadata keys associated with your vector. There are different related concepts which you would like to explore, where you want to go next. If you built your Bedrock agent, you are happy with it, you want to bring it to production, you may want to migrate it to Bedrock Agent Core, also to give your agent production features like observability, code interpreter, memory, and get flexibility, basically to convert your Bedrock agent into real code. And also, I mentioned this option, you can combine S3 vectors and Amazon OpenSearch Serverless, so you can bring cost efficiency. S3 vectors will bring cost efficiency, and OpenSearch Serverless will bring low latency, high performance. This potentially interesting and also potential interesting use case, how you can use S3 vectors to create and semantically search a media lake on AWS. So with that, there are key takeaways from this presentation. The first one, we introduced Amazon S3 vectors, which is the first cloud object store with native vector storage and a query support. They can be easily integrated with a number of AWS services, and they allow us to build semantic search and RAG applications without going into high costs. So I hope it was enjoyable and interesting for you. I'm looking forward to seeing your question and address to your question. Thank you so much.
Hey everybody, I'm super excited to be here today to talk to you about automation, serverless, and an event-driven approach to DevOps. So about 1 year ago, me and my team was looking at our AWS environments and realized that we might have a problem, or actually several problems. There were several things we thought this needs improvements, and here is something we need to look at. We as a team, we are responsible for our AWS setup. We are responsible for our AWS accounts, the security, our container clusters, and much, much more of that. So we as a team, we take care of some of the heavy lifting, so our feature teams don't have to worry about that too much. So today, I'm going to take you on a journey. I'm going to tell you the story about how we started to improve our DevOps, our automation, productivity, developer experience at My Money. I will tell you the story from the beginning, how we step by step changed and improved. I will talk about where we are today, what the future holds, and we will deep dive into our implementation that has gone through several iterations, actually. And in the end, I actually hope I will inspire you all how you can change and improve your DevOps, automation, and developer experience. So, but who am I? My name is Jimmy. I work as a principal cloud architect at Sambla Group. I'm the founder of serverlesshandbook.com, where I collect all my serverless adventures, tutorials, solutions, and blogs. I'm an AWS serverless hero and a user group leader for the user group in Malmö and in Stockholm, Sweden. And when I'm not talking to you about DevOps and serverless, I do a lot of barbecuing and grilling. So looking at the agenda for our next 30 minutes, I will tell you our journey, the story about our journey. We'll do an implementation deep dive, and then we will look into the future and what the future holds for us. So, but let's start with the journey and what actually brought all of this into play. But before we do that, I need to tell you a bit about My Money. My Money is part of Sambla Group, where I work today. So My Money is a fintech company that is based in Sweden. We are a loan broker and focusing on car financing. So basically, we are a man in the middle between car dealerships and banks lending money to private persons when they want to finance their cars. We have business hours between roughly 8 a.m. in the morning to 8 p.m. in the evening. That's basically when the car dealerships are open for business. It spills a bit into like 8, 9 in the evening, but primarily we see traffic between 8 a.m. and 8 p.m. So the first thing that started everything was actually cost. It was all around cost, and we had 3 environments: dev, test, and production. And all of these were running 24/7. But of course, none of our developers was working 24/7. We are all based in the south of Sweden. We are in the same office. And there was actually no point for us to keep these development environments running all the time. Even if people work flexible hours, we could see that people start working around 7, 8 in the morning and left the office around 5, 6 in the evening. This was Monday to Friday. Outside of these hours, we basically don't have any activity in our development environments. So we took the decision that we want to shut down our development development environments outside of our business hours or our office hours, meaning 7 in the morning and 6 p.m. in the evening. And we keep them off during the entire weekends. We also looked into our production environment and how we were using the usage in that. We decided that we could actually scale down our production environment during the evening. As I told you, we can see traffic between 8 in the morning and 9 in the evening. During that period, we were running 2 tasks of each ECS service. But during nighttime, even if one task would fail, it will be spun up again. And with like a 2-3 minutes outage in the middle of the night wouldn't be that big of a deal. So we decided that we could also scale down our production environments to roughly half. So we went ahead and we built this automation. We built it based on Amazon Event Bridge and step functions to create it. The second part that drove this change, or the second problem we saw, was around security. Working in the fintech area, IP allow listing is still a big thing. Meaning we hand our IP addresses to our partners and they hand us their IP addresses. And we have a mutual trust on IP and we only allow traffic from certain places. Now, in our development environment, we have the same setup, but for developers to be able to work from home, they needed to add their IP address, their home IP address, to that IP allow listing. And we all know developers, we are lazy, so people forgot to remove their IP addresses. That meant that we discovered that at some point in time, we actually have around 50, 60 IP addresses in this allow list. And a lot of them was home dynamic IP addresses, meaning that anyone could now have that IP address. So we decided what we need to do is we need to reset this allow list every night. And we built that solution also on top of Event Bridge and step functions to every night reset the allow list back to its original state. We also needed some notifications around security findings. We are running Macy together with guard duty and config. And we wanted to know if any of our rules was failing, or if Macy detected new personal information that wasn't encrypted as it should be. We needed those notifications as well in one single place. And the last part was around operations. We needed an easy way to operate and monitor our environments. We needed an easy way to perform simple operations without our developers breaking their back. And we wanted to create a single pane of glass where we could see all of our things that was going on inside our environment. And as an icing on the cake, we wanted to be able to create an audit trail of what is actually going on. So we implemented all of this, but we did not really anticipate the pushback that we got. The first question we got from our developers was, what if we need to solve a critical problem during the weekend? Car dealerships are open during the weekend and things could happen. Well, we thought everything was just simple. You log into the AWS console, you go to the production account or the development account, and you run these step functions with these parameters, and the environment will spin up. That was not really taken well. Teams thought that was a bit complicated, and they wanted, no, that's too much. We don't want to do that. We want something easier. So we had to take a step back. And we had to figure out what problem is it we want to solve. What we wanted to solve is we wanted to reduce cost by shutting down environments and hibernating environments when they were not being used. We wanted to increase our security by resetting our IP lists. We needed monitoring and getting security alerts back into our environments. We wanted an easy way to operate our environments, a single pane of glass, and an audit trail. So we needed an easy way to perform these everyday tasks. We wanted one platform for notifications and performing tasks. And we wanted to reduce the context switching, moving back and forth between AWS accounts. So we looked at our tool landscape, and Slack was one tool that was common for all of this. We use Slack for our daily communications, sharing information, and so on. Everybody is on Slack all the day anyway. So could we use Slack to do this? Already today, AWS has built an AWS chatbot for Slack that you can integrate. However, it didn't really had the specification of and didn't fulfill the needs we had. So we were thinking, can we use Slack anyway? And yes, we wanted to bring as many tools back into Slack as possible. We wanted to automate as many processes as possible, and we needed to remove the obstacle and make everything easy. So we decided to build our own integration, our own My Money bot, that we could integrate with Slack and our AWS accounts. We built the bidirectional communication between AWS and Slack. We had notifications and alarms flowing, and we had commands flowing from Slack into AWS. But we needed to distinguish it between thin and thick work. Basically, when do you use Slack and when do you use the console or IIC and similar. We needed to create an audit trail as well, and Slack would be the perfect place to see that, to see like, oh, okay, who added the IP to allow list and so on. Not for blame, just because we needed to figure out who was doing what in our environments. So looking at some examples on how everything was looking. So when an environment starts or stops, we get a notification saying that the status of an environment has been updated. It specifies which environment, which service, and what it's been doing. So in this example, we can see that our prod environment has stopped the client VPN. It has scaled down the ECS services. We can also see that the development environment totally stopped the RDS database and stopped the ECS services. We had also integrated everything to our Okta or Auth0 implementation, meaning that if you want to test a service running in the private part of the VPC, we use machine-to-machine tokens for the communication. So if you want to mimic one service calling a different service, you could just enter a command in Slack, get the machine-to-machine token, and you can use that in your daily tests. These messages with a token is, of course, only visible to you, and they expire after a certain time. We also could see that our WAF IP addresses, so the allow list has got updated. We could see which IP address that was allow listed. We could see the user who did it. And we can also see in the evening that our lists are being reset back to its original state. And from the alarm point of view, we get the alarm state changes sent back to us. So here we can see that one of our circuit breakers has gone off, triggering an alarm and letting us know. We can also see on the right side that we got a message sent to us in the DLQ for some reason. So quick summary of this first part and the setup of everything. What did it actually give us? What the benefits and outcomes did we had? We actually reduced cost with almost 60% by shutting down and hibernating environments and scaling down our production environments. We improved our security, and now it's very easy for us to handle our allow lists. We reduced the context switching. You can do a lot of things from Slack where you already am. And it has an easy way to do easy everyday tasks. So let's move over to looking at some of the implementation and do an implementation deep dive. The goals of our implementation was to build everything on a serverless and event-driven manner. We wanted to have modular building blocks, making sure that we can easily extend and remove things. And we need a multi-account support. So looking at our account integration on a rough picture, this is what it looks like. All our different environments is running in a separate AWS account. So we have one account for dev, staging, and prod. Now, Slack and our Slack bot needed to communicate with a single point. So our Slack is now communicating with our AWS service account, and then everything fans out into the correct account. So adding a few more details, Slack calls an Amazon API gateway. We do authentication and authorization in that with a custom Lambda authorizer. Then a message is put on an event bridge bus, and that fans out targeting the correct account, meaning if you're targeting the development account, staging account, or the production account. We also do some filtering here because we don't want anyone to be able to shut down and stop our production account. So we do the filtering. So if anyone would just write that they want to stop the production account or the production workload, that would never reach the production account. Zooming in a little bit more, adding a few more details, we can say we have a Lambda function that's doing the filtering. And when the filtering is done, it adds a command onto the Amazon Event Bridge command bus, which then is sent over to the correct environment account using a cross-account rule. On the bottom part, we can see we have messages flowing from our different environments accounts into Slack and our service account. That is logs, alarms, and so on. That is flowing on one path, and commands is flowing on a different path. So some of the design decisions that we made was to use multiple event buses. We wanted to have one bus for commands and one bus for system messages, basically splitting it up on a domain-specific use cases. We also decided not to have any form of direct integrations. Sure, we could do a cross-account integration nowadays, having the event bus in the service account just invoke the step function directly in our environment account. But by doing that, there is a risk that we're starting to leak business logic into the service account. And we didn't want that. We wanted to isolate the business logic and what we are doing inside each environment. So if, for example, the dev environment needs to take an extra step that the staging account doesn't need to do, our service account don't need to know about that. It only needs to know that I will post this message on my event bus, and we have this bus-to-bus communication. The same flows on this bottom half. The system message is flowing over an event bridge bus-to-bus communication. And of course, we are not using the default bus at all. It's all custom buses throughout the entire thing. That is best practice. Never ever use the default bus for your custom things. Leave the default bus for the AWS services and the AWS messages, and implement your own custom buses for your own applications. So if we're going to do a bit of a deep dive on our operations or command process, as I said, we already said, commands flow from Slack into the service account and then hitting the environment account. Zooming in on the environment account, we handle each of these commands separately. We can also have it running on a schedule, having event bridge scheduler, triggering different things at different points in the day. And how this is implemented is that we have decided to make sure that each of our operations has been implemented as its own smaller service. So we are isolating how to allow deny IP addresses and starting stopping environments. This gives us a very flexible and easy way to extend any functionality. If we need to do something else, we just add a new mini service or microservice in the account that do the operations that we want, and add a message onto the event bus that is starting to listen at. That way we can extend all of our operations, we can remove operations in a super easy way. Now, I want to deep dive a bit into one of the more complex flows that we have. I want to deep dive into the start and stop part of everything. So, how does that look? Looking at the environment account, the messages start flowing into Event Bridge to start or stop an environment. This can also be triggered by a schedule, so starting a dev environment every morning or shutting it down every night on a schedule. We handle everything, even if it's on demand or if it's at a schedule. We handle the flow the exactly same way. It's just a different way how the command is triggered. So the first thing that's happened is that the message ends up in a step function that do some processing and adds a message into a separate event bus just for start stop. This third event bus is there to make sure we don't leak any business logic outside of this flow. Then first part of everything is an event that triggers our step functions to shut down our ECS services. Our ECS services scale down. We wait for them to be scaled down. And when that is done, our step function posts a message back to Amazon Event Bridge saying that, hey, services is now not running. That creates a new message being sent to next step function. That step function is then now responsible for shutting down and hibernating the Aurora database. And when that is done, a message is flowing back into Event Bridge and triggering the last part of our environment start stop, meaning we start shutting down our client VPN. So looking at the step function for stopping the database, we will start by checking, is the cluster already running? If it's yes, we do a start or we do a stop. Then we start just waiting here until the database has been started or stopped. And then finally publish a message onto Event Bridge. So looking at this flow, it's all built as a saga pattern, where events flow into Event Bridge, triggering different parts of our saga pattern. We combine choreography with orchestration, getting the benefits from both the worlds when building this solution. As I already said, we can both invoke it on schedule or on demand. How it's being invoked doesn't impact the flow, it's just different ways to trigger the same exact flow. And this, using the saga pattern, using choreography together with orchestration, give us a super flexible and extendable way. If we want to do something more during a start-stop, we can just add one more step into this saga, and everything just flows as expected. Now, looking at the monitoring side of everything, this is more of a push. So here we are pushing information from our different environment accounts into Slack. We have our direct sources, which could be CloudWatch, Macy, Inspector, Config, and so on. All of these are direct sources in the meaning that they evict messages onto a default Amazon Event Bridge that we can listen for and then pick up in our own system bus and send over to our service account and make it end up in Slack. Then we have our indirect sources. That could be SQS, ACS, or the load balancer. What I mean with indirect sources is that these trigger alarms that we have been creating in CloudWatch. So we have an alarm if a message ends up in a DLQ on SQS, or if there's something problem with ECS, or we see too many error message on our load balancer. That will trigger alarm in CloudWatch, and CloudWatch will then push the message over to us. What this gives us, it gives us security alerts. We can get security alerts if some of our config rules are out of spec. So if, for example, our encryption is not correct, or if we have an S3 bucket that doesn't use correct setup. We can push if Macy finds personal information that has not been correctly encrypted and so on. It gives us infrastructure alerts, meaning that any part of our infrastructure starts to fail. And it can give us application alerts. So we have circuit breakers in our code. If for some reason one of our third-party integrators, some of the banks, has any problem, we have a circuit breaker that will be triggered, and that will end up as a message in Slack. So we get all of these alerts pushed from our different environments into Slack in a good way. Now, looking at the integrations part, how is that built? As I already said, we have two buses, one for commands and one for system messages. Now, I've been talking a lot about Slack, but we decided early on that we wanted to build this extremely flexible. Sure, we're using Slack today, but that doesn't say that we will use that forever. We're also using Microsoft and Microsoft Teams, and someday maybe someone will say, hey, we will stop using Slack. We want to move everything to Teams. So each of our integrations is isolated and built in a super easy way. So if we want to add a Teams integration, we just implement the logic that is needed to communicate to and from Teams and hook that into our different event buses. We could also build like a status page and have messages being pushed to that, and we implement a logic how to update the status page. This creates a very easy and flexible way to extend our integrations by just being able to build the small part that is needed just for that single integration. We kept the information saying that we want to keep the common event buses. And the reason to keep the common event buses is that it makes the integration so much easier. So we have the event buses running in our service account, and if you want to build a new integration, we just hook into the existing event bridges, and all of the logic in the environments account we just do the same. We just need to implement the business logic for the integration. Now, looking at the future, what is ahead of us? We've been working with this solution for almost a year, on and off, and definitely not working full-time with it, but around a year on and off. So what does we have for the future? We want to create more post-deployment monitoring, meaning that every time a new service is being deployed, we want to be able to monitor that. We need to get notification if something fails, or if we need to roll back. It would be great to be able to integrate an account management into this. So be able to spin up sandbox accounts for new developers and making sure we deploy everything as best practice. We also want to be able to run tests, maybe start our entire test suites from Slack and get all the messages back to us in real time. So I've been talking about around 27 minutes without mentioning Gen AI. But of course, we need to put Gen AI into this as well. What we want to do is have some form of assisted error debugging, actually be able to chat with the logs, understanding what is going on, have the LLM translate a lot of logs into human readable messages, informing us what is going on. Also wanted to build a documentation search based on RAG or something similar technologies to be able to search our entire documentation. Today we're using Confluence, and everybody knows that Confluence is basically go fish if you want to search for some part of the documentation. So by integrating this into Slack with RAG and LLM, we can be able to search our documentation in an easy way and chat with our documentation. And of course, agentic workflows. We have built a good REST API and everything today to be able to do all of these operations with Slack. By building an MCP server for all of this, you could actually be using your Copilot installation and things like that to issue commands directly to our setup and be performing starting and stopping using an LLM. So that is some of the parts we are looking into for the future. With that, I say thank you all for listening today. I hope you enjoyed my talk. And if you want to connect with me, please scan the QR code for LinkedIn. Thank you.
Hi, everyone, and welcome to this session. Okay, I need my slides in this. Okay, perfect. Thank you. Hi, everyone, welcome to this session and to this amazing event. I'm very, very happy to stay here. Today, we are talking about how to use an event architecture to solve compliance and security issues. We start with the first thing, that is a introduction of the topic and about me. I'm Miguel Ángel Muñoz, cloud architect at Logicalis. I'm from Spain, and I am AWS ambassador and AWS community builder, two amazing programs on AWS. And if you can read, you can search on the web. Also, I have few certification, and I have two blogs, Cloud hasta la sopa in Spanish and Soap to Cloud in English. Okay, we talk about security on AWS, and I like to name this topic or these things about security layers. When you deploy a workload on AWS, you need to secure your workload, to protect your workloads, and you use multiple layers. Not only one, but you need to protect with multiple layers. One layer can be AWS security stack, all AWS security services that help you to protect your workloads, like Inspector, like WAF, like Network Firewall, or other any AWS services, or GuardDuty, for example. And also you can use EM policies, in security policies, to protect the action or block some action, some bad action that the user cannot do it. For me, the third layer, maybe you can implement an infrastructure as code custom brochure. If you use Terraform or CloudFormation or CDK, you can use modules or stacks or construct that follow your security baselines and your compliance baselines, and create a resource that you can share with your team, with your company, to not permit them create their own resources. The fourth layer for me is deployment security policy. You also can put security policies when you are deploying your infrastructure. Before this, you can put a deployment policy like Terragram that check if your deployment is following the baseline, okay, the security baselines. Okay, these layers are good, but sometimes they are not enough. You need more security. You need to add more security. And for this, I like a new layer that is event-driven security. Okay, that is use event on your application, or in this case on your AWS services, to protect your workloads and block bad action. Okay, why this layer improve for security? Okay, because it's an extra layer. I told you you don't need to use one of them, you need to use more than one. And if someone breaks your security layer, that can happen, you have an extra layer to inspect the event that happened in your account and put a remediation of this. Also permit a deep inspection. The event pattern permit to inspect the events and think that the user can and inspect that what the user is doing, and also permit a fine-tuning. If you are using policies, for example, conditions are a pain in the butt. It's very hard to put condition in a IAM policy because it's not very flexible. With this layer, you can do this. Okay. An event-driven security architecture is like any event-driven architecture. It's very, very simple. And I put a brief example about you need an event producer, okay, a service or anything that produces event for you and send to the event to an event router or broker. And the event router broker with rules send this event to event consumer to do actions, okay, to inspect the event and take the action, okay, to do different action. For event producer, about security, we have CloudTrail, Inspector, Guard Duty, Macy, Config, and any other AWS security service can send events about security. And you can send this event to Event Bridge. That by default, you have the default bus that all AWS events send events to that default bus, or create your own bus. And you can create rules to invoke any AWS compute service, like Lambda, like Fargate, like Step Function, or other AWS services, or other compute services. Okay, we had a little introduction about the topic, and now we talk about use cases. What use cases are good for that event pattern? Okay, and we explain a problem that I had a lot of times in my career. That's problem repeat one and another time, and that's problem happens in a lot of different customer, in a lot of different organization, and it's very common. Okay, so one developer open a security group, they open the 22 port, the SSH port, to the wall. Okay, the developer thinks that this security group only applies to a private instance or a private resource, to a private subnet. But someone attached this security group to a public instance. And in that moment, we have a problem, because a malicious user watch that the SSH port is open and start to try different password. That happened in seconds. It's very quick and very dangerous. And when that happens, not all time, but usually you have a compromised server, okay? The malicious user can enter to your server, and oops, that is a big problem. And you can joke about this, but that happened a lot of time in my career on AWS. I worked in AWS environment for 7 years, and that is very common. Always happens, and it's a big problem because you can lose data, or the malicious user can try enter to other systems, and that is the worst thing that happened on AWS for me. Okay, how to solve? That is very hard to solve with other security layers, because, for example, the only layer can help to us is the deployment policy. To put a deployment policy, because for example, IAM security policies don't block action. You can block action to modify the security group, but not to modify what IPs can you put on, or what port can you put on the security group. And also with deployment policies, it's okay, but if someone entered to the console, doesn't apply. And how to solve? Okay, we have two actions that modify security group ingress, authorize security group ingress, and also modify security group rules. These two options are on CloudTrail. If you don't have CloudTrail enabled, please enable it, because it's mandatory and it's amazing AWS service, and the first trail is free. Okay, we can catch these two apps. We have this visibility of these two options, and we can send these two actions to an event bus. By default, AWS send to the default bus, okay? And we can create rules, okay, on Event Bridge. Event Bridge permit to us to do this. How? Okay, maybe it's tiny, this slide, but I will explain. It's very easy. Okay, you need to put the event name, that is authorize security group ingress and modify security group rules, the event source. Okay, that is tricky because a lot of people think it's CloudTrail, cloudtrail.amazonaws.com. No, in this case, the event is EC2 because security group is part of EC2. EC2 Amazon, amazonaws.com. And the detail type is CloudTrail, okay? And the source is EC2 also. Maybe you don't know how to catch this event or the parameters to put on the event bridge rule. To do this, usually it's helpful to put the event bridge to a CloudWatch logs, okay, and do the action and catch the events, and you can understand how the events works. Okay. Next, when we have the rule, we need to evaluate the event, and if the rule, the security group is bad, okay, revoke the security group ingress. That is an action. We can do this with a Lambda. With Boto 3, it's very easy. With Python and Boto 3, it's very easy to do this in a code. Okay, now is demo time. That is implemented on one of my accounts, and we watch how it works. Okay, we have the full setup, the event bridge with the rule to invoke a Lambda, to not permit SSH rules to public IPs. Okay, I will create an all traffic to the world. That is a bad rule. Okay. Also, we will create an SSH rule to the world, also to 000, and SSH rule to a private IP. Okay, that's, for me, that is fine. I don't like, but in this case, it's fine. I prefer using other method. Okay, and also HTTPS to enter to the 00, okay, to the world. That I will permit this rule because it's good for me. Okay, it's present HTTPS to the world. And okay, the rule start, the rule are invoked, the rule catch the event, send to the Lambda evaluate, and delete the rules. Very quick. And now we will modify the good rules to bad rules. Okay, change HTTPS to SSH and the private IP to a public IP. Okay, done. And happen the same. CloudTrail catch the event, send to the event boost send to the rule invokes the Lambda and delete the rules, the security group rules. And it's very quick, it's in seconds. That is a real implementation. That is a record from my account in real time. It's not, I don't modify the timeline. That is in real timeline. It's in seconds. That is very quick. Okay, another example of this, of how to use an event bridge and event driving security architecture. It's, for example, to attach a WAF to ALB. When I put an ALB, I don't want to be insecure. I need to put a WAF with rules. How to do this? Okay. Someone create the action. That is, the action is create load balancer. The event boost has this action. The rule catch the event and send to a Lambda. And this Lambda modify the listener to a fixed response. Don't delete the application load balancer. Only modify the listener to fixed response that say, okay, you need to solve a problem with the ALB. Okay, associate with, if someone associated with ACL, okay, if the WAF is associated, send to the event boost, invoke a rule that's invoke a Lambda, and this Lambda restore the listener configuration. If you attach the WAF, that is cool. Okay, maybe we need more events to not permit modify load balancer or disassociate with ACL, but the main thing is this. Okay, and I want to add an example of the rule here that is, for me, that is important because, okay, what happens if I put a private load balancer? Maybe I don't want to force to attach a WAF for a private ALB. Maybe I can do this in the Lambda. Okay, in the Lambda it's easy. I can evaluate and I can watch the event, and if a private load balancer, I can say, okay, don't touch anything, don't do anything. But at the same time, it's a good option or a best practice to reduce the invocation of a Lambda. Okay, To do this, we will add in the pattern, in the event pattern of the rule, the one thing that is the request parameter. In this case, is schema internet facing. With that rule, that is very, very similar to the rule from security group. That rule only apply to only invoke the Lambda if the ELB is public. Okay, if it's private, don't apply the rule. Okay, will be next. What happens if we need a more complex workflow? Maybe we need put more security or follow compliance in a more complex workflow. For that, we can use step function. In this case, I will do with when something run an EC2 instance, the same pattern, okay? But in this case, instead, invoke a Lambda will be invoke an step function, okay? And the step function is very easy in this case, okay? The step functions will be wait to the instance is running, okay? Because take some time, few minutes, okay? And the first thing is a choice state, okay? Choice the operating system. Review what operating system is this EC2, okay? If the EC2 is a Linux, we will run a patch baseline for Linux, or if it's Windows, I'll run patch baseline for Windows. You can implement more more choices of operating system, like in Linux, if it's a Ubuntu, or if it's a Amazon Linux or other Linux operating system. And the next step is check the compliance check. Okay, I need to put specific agents to this instance to follow my security rules, because my security teams need this. Okay, I check if these agents are installed. If not, I run a system manager automation to do it. If are installed, I only add to the CNDB. In both cases, I will add to the CNDB, okay? That is the last step. And you can do anything with a step function. Step function is very powerful system and helps you to create more complex workflow that, for example, is more complex. You can do this with a Lambda, okay? To orchestrating different lambdas, but it's hardest to do. Okay, with Event Bridge, it's easy to do, and also Event Bridge has a lot of integration directly without use a lambda, like the system manager. And now we are talking about security, but maybe we don't need anything about security, or maybe we need to cross an account. Okay, we need to, and I explain a networking problem that is very typically for me, and I think for all people. That is, what happens when do you need to accept a transit gateway attachment on infrastructure as code? On Terraform, that is easy because you can use different providers. Okay, one provider for the member account, another provider for the networking account. But with CloudFormation or with CloudFormation or CDK, it's very hard to do this because they can't change the account directly. Okay, you can do this, but doing very tricky things, and in my case, I don't like how to them implement this. Okay, but you can do this with an event pattern. Okay, with an event driving architecture. Okay, we will wait. Okay. The action is create transit gateway VPC attachment on the member account, send to the event bus, and catch with a rule. Okay, instead execute a Lambda or any other compute service on the member account, we will send this event to a networking event bus. We can do this, okay, with a rule or directly with the event bus, but you send all the event bus. In this case, we will do with a rule to only send the events from the create transit gateway VPC attachment. Okay, and also I can create a rule for that and invoke a Lambda and that Lambda check if the VPC attachment is fine. Okay, is if from an account on my organization, or an account on a specific member account, or the account have a specific tag that permit this. I can evaluate with different ways and affect the transit gateway attachment. And that's a pattern, or that use case is fine for networking, but also you can use in security, because instead, for example, execute all execution from Lambda from the member account, you can do this on a centralized account, and you have the full control of the Lambdas, the full control of all things. You only need to create you need only create rules that send your events to other account. It's more expensive because in the other case it's very cheap, but in reality it's not very expensive. Okay, we talk about few dollars. Okay, and we talk about the final thoughts about this. Okay, the event-driven architecture we talk about only for AWS services in security or networking, but any AWS services can do this. You can do it with management and governance when you create an account, when you move an account from a OU. For example, you can do it this if you want to delete all the resources. You can move to a specific OU, catch the event, and run an AWS nuke, okay, to delete all resources on your account. Or maybe on compute, when something creates an Elastic Network interface, check if that is good or is public or not. That is a good thing about this. Also with databases, also with networking, and also with security and identity and compliance. Like, for example, a typical use case of this is when guard duty detects a problem. When guard duty detects any security issue, like your instance is compromised, or like someone is trying to attack you, or someone are try to export information from your servers or from your data to outside. You can detect this and do an automatic action, okay, like a block this pattern, okay. That type of event-driven architecture is very helpful for this. And my final advice about this is useful for many use cases. I used this event pattern with different cases. Usually I centralize the event bridge only in one account, on security account, and check different patterns. Check if someone doing any bad action, create a Lambda create a Lambda, I don't know, with all code, very not updated code. Or I check if someone tried to do any bad behavior, deletes things, or any can be problematic in my account. Also, I was an infrastructure guy, and this type of architecture is very good starting point for infrastructure guys, because it's a very good way to understand how AWS works and to unleash all the potential of AWS. Try to do a lot of different action in more automated way. When I started on AWS, all people doing things in manual way. Okay, I enter to the console and deploy on the console and delete resources on the console. That is not very a good way. With this, also now I use infrastructure as code by default, but also you can do a lot of different actions when something is acting on the console, or when you need to execute automated actions. Is a very good thing, and it's a very good way to start with event-driven architecture if you are infrastructure guy, because usually for a developer is more common know what is an event-driven architecture. For me, when I when I listen the first time, I don't know what is. And also, it's very cheap. You can do this with AWS config, but it's very more expensive because EventBridge is very cheap. The default boost is free, and the events are very cheap. You need to raise a lot of events. Lambda, for that use cases, is very cheap because our execution in milliseconds. The longest time that I did a Lambda for this is 300 milliseconds or 400 milliseconds, and the number of execution is very low. And also, it's very easy to sell to your manager. Because automation is very easy to sell, but at the same time, because it's cheap and it's a good way to improve your security or improve your security, your infrastructure, or reduce your manual tasks. And I like it this. And for me, when I sell this to different customers, to different organizations, it's very easy. All of them buy this type of solution. And that is all. Thank you. You have here my link tree if you want to connect with me. If you have any question, you can connect with me or send in a form. I will try to share my slides, and I hope I was lucky to you to win the raffle. If you win raffle, connect with me because I will go to remain this year. And bye.
Hello, everyone. The name of my talk is "What Netflix doesn't tell you: How they stream live with AWS Media Live and Media Package." First, I'm going to present myself. My name is Luis Valdivia. I'm from Peru. I have 15 years of experience in software development. I have 4 certifications of AWS. I currently working as a CTO in Plus One, which is a software factory here in Peru. I work as a certified cloud architect, and this is my second year as a community builder. The agenda we are going to talk about as a introduction, key concept, what is live streaming, how does it work, what is AWS Elemental Media Live, what is AWS Elemental Media Package, architecture, and some examples. A brief introduction. Besides working as a software developer or CTO in Peru, I like a lot WWE. I'm a very huge fan. I've been a fan since I am 10 years old. And the good news for me is that Netflix signed an agreement with WWE this year, so we can watch all the pay-per-views and the last round of the greatest champion of all, John Cena. Why Netflix is using live streaming? Because Netflix was born as a VOD on-demand service, where you will be able to play series, movies, and so on. Streaming is a big part of our life. Some of us don't need to use a TV signal. We only turn on our TVs and play some videos from any of these apps: Prime, YouTube, Netflix, Crunchyroll, or any others. But how does it work? Before learning how does it work, I want to define some key concepts: RTMP, HLS, encoder, playlist, and quality. RTMP is a protocol which allows us to send these videos to our final destination, which can be smart TVs, mobile devices, or any other streaming device. HLS is a protocol which allows us, as a final users, to play these videos. As many of us know, if you record a video on your Android device, it has a different format if you record your video in an Apple device or even in your laptops. Which HLS, we normalize these formats to be able to be played in any of these devices. An encoder is like a box like this, where you can transform your air signal to digital. Because if you are used to watch TV of your local news with your air signal, that signal has to be transformed to digital. And with an encoder, you can do it. A playlist is like a manifest. If you are working as a DevOps, it's like a manifest where you create some syntaxes which allow us to be used with an HLS player. And then we have quality. Quality is the easiest. When you enter to your Netflix account or Prime account or any streaming account, if you have a good internet connection, you will watch your content in very full high quality. But if you have a poor internet connection, you will watch your video in a very pixelated way. So what is live streaming? As Cloudflare said, streaming is the data transmission method used when someone watches a video on the internet. What application do we have? Pluto TV is a very popular application here in my country and in all Latin, where it's free and you have several channels that serve content, Naruto, animes, movies, and any other things. Then we have Netflix, which streams all the pay-per-view videos of WWE. We have TikTok, which is a very famous social network. So what is live streaming? We can define it in 5 parts. Source is, it can be a smartphone, a laptop, an encoder, or any other streaming device that you can have. Codification is the part where these raw videos are sent to be transformed. And which is the one element that transforms these videos? The media server, which can be a RTMP or HLS server. This transforms this video in very small pieces of videos with an extension TS, and then these all parts are sent to a distribution. Distribution could be CloudFront, Cloudflare, or any other CDN that you want to work with. This content is sent to the final user, which can be reproduced in HLS player or any streaming application that you have. So we are going to talk about some services that maybe are not as popular as EC2, Lambda, and all the mainstream services that we have that AWS provides. One of these is AWS Elemental Media Live. Elemental Media Live is a cloud-based broadcast-grade video processing service with the ability to deploy live channel in just minutes. Just minutes. Remember this part, just minutes. If you are, if you have the opportunity to work with live streaming, not in the final part that you are watching the final content, if you are in the backend part, maybe it's very popular for you to know WOSA. WOSA is a software that you can install on your server, and you can do the same thing that AWS Elemental Media Live do. But the main problem with WOSA is a software. You have to install it on an EC2. You have to configure all the security rules that you have learned in the previous talk. You have to learn about WOSA because WOSA has a learning curve, and you have to make some additional customizations that can take you minutes or maybe months because you have to learn. But with AWS Media Live, we can do it in just minutes. In some moments, I will create a small demo for you, and you will check it. Then we have his little brother or his brother, Elemental Media Package. Elemental Media Package is also a cloud-based video packaging and origination service that prepares, protects, and delivers video and on-demand streams to a wide variety of multi-screen devices. Elemental Media Package is like a brother of Elemental Media Live. They can work together. Elemental Media Package give a lot of strength to Media Live. You can protect your signal. You can maybe record your videos on real time. You can, I don't know, if you are watching something live, for example, a boxing match, if the boxing match starts at 6 and you enter 6:15, it shows you a little pop-up that says, do you want to play it live or play from the beginning? With Elemental Media Package, you can control that. You can control your video. You can control the pass. You can go 5 minutes before, 10 minutes before, or to the origin. You can do that. We are going to watch a small architecture. This is like a proof of concept. Then you can make some crazy things, but this is the base. In the base, what you need is your source. That can be as a mobile device, media Media Life, Media Package, and CloudFront. That is, with this architecture, you can deploy your live streaming in seconds. This is the basic part. Then you can add Lambdas, WAF, and any other things. I'm using all the services that AWS provides, but you can change this to any other CDN. This is the basic. So this is the repo that I have created and a small player that you can check. I'm going to prepare this demo with you. You can do it with me. You can follow my step. I will not use all the qualities that Netflix does because this is a proof of context. You can then increment, decrement, or do whatever you want. And then I'm going to share my screen again. This is the console that we are very familiar, but we are going to look for some services that that are not very popular. Media Life. Media Life works with two important concepts: input and channel. We are going to create an input. We go to the input section, create input, and we select here our configuration. I will call this input test, and I will going to use RTMP push. Because why push? Because I'm going to send the signal. I'm going to use this program that maybe you know. It's loading, it's loading, it's loading. Here it is. I'm going to send this small video like a live transition. A part of being a WWE fans, I'm a huge fan of Blue Lock. So I will send this like a live video. I'm going to say RTM push. I'm going to just use AWS. You have to use public, and then this is a proof of content. I'm going to use public, and I'm going to make some things that in a production environment should not be done, but this is a proof of context. I'm going to create a security group. In this case, I will use this. I create my security group, and I have this configuration: a standard input and single input. The big difference is if you use a standard input, you can have two signals running. You have redundancy. But as many as we know, redundancy has a greater cost. In this proof, I'm going to use single. If you are in production, you have to decide, I need to have redundancy, or I only need one. It depends. Destination, Spring. Create input. We have created our input. One little thing is that media package doesn't have a free tier. You don't have. Maybe you can use your credits or do something, because this example doesn't cost around less than $5. Now I'm going to use media package. Media package use the same concepts. In media package, you have to create a channel. You create a channel. You give it a name. Then you can hear if you want to collect some logs when you receive your signal, and when you send your signal, that is send it to CloudWatch. In this example, I will not use it. Here is, we have to 2 points to ingest our signal. This is handled automatically by AWS. You don't have to do any crazy thing. You don't have to work with secrets or any other things. After we create our channel in media package, we are going to create our endpoint. In this endpoint, we configured a name, a description, a manifest. A manifest is like is the playlist. The playlist is like a file that is created to handle all the qualities and all the crazy things that we're going to do. And then, as I mentioned, I told you that we can control the video with this param. We can control our video until 14 days ago. We have that opportunity. We can make our video to go to the past and return to the present with this. But the only thing that you need to know is that only is 14 days ago. Here is the format that we're going to use. We're going to use HLS. The segment duration, we are going to leave this in the default configuration. And we are going to save it. We have created our channel. I'm doing this by console to explain all these topics, but you create a template on CloudFormation or in Terraform if you want. Now, we are going to the main part. We are going to create a channel. I'm going to start this one for the ones that is scan the QR code to see the streaming, but we're going to create a channel. I'm going to create a channel. This is demo 2. A very important concept. We have created an input, and we are now creating a channel. If you want to use an input, you have to remember something very important. An input can be only attached to a channel. If I go back here, I have 2 inputs, this one and this one. And in the console, it only shows me this one. You have to remember that. It's very important. 1 input per channel. We confirm. Then we have here a lot of configuration that we can handle, like blackouts, buffering, and other things. But I'm going to do it the easy way. If you have scanned the repo code, I have attached a small JSON file that you can test and you can check it. Here it is. It's a small file where I can configure the quality. I am only using 1 to be cheaper. You can check it. You can change it. You can do whatever you want. This is a small proof. I'm going to upload my template. Upload, and automatically it creates a quality. What you need to know is that AWS Media Live charge you by quality. I'm using a small one, but you can do it. You can change it. You can add more. You can do cool things that I'm not doing. And then, after we have created our quality, we have to point this media live to a media package. In here, we go to media package group and we select the one that we have created. In this case, I'm using demo. We do this and we create a channel. One thing that you have to remember is that this template will show you this error. You have to create only this role to be accessed by media live. And we create this. We wait some minutes or maybe some seconds, and our channel is going to be in state create. we want to test this one. That was the one that I create to do the repo example. We go to our encoder, in this case, OBS. We go to settings, stream, and you will set, Luis, where we get these values. These values, we go to inputs. The one that is using is WR. We go here, and we have here an IP. We go here, we copy the last part. We are going to use it as a string key. Apply. Okay. And start streaming. We have to wait some seconds because it's starting like an EC2 or RDS. We have to wait some seconds until we can use it. But if you see that is green, we can test it. You have two ways to test it. If you have turn on your channel, you can go to your channel and you will see some small previews. You want to test it. We go to media package. The channel I'm using is the invent. We go here to find origins. We copy and we paste it. We have to wait some minutes. It's playing. And maybe if you visit this small website that I created, you don't know if it's VOD or live because it doesn't show you that it's a VOD. You can put this link in your website and you can play it. But a small thing that I want to show you is something like this. If you are in a Windows computer like me, maybe when you open this URL, you will see something like this. I have a special extension in Chrome to be able to play it, because if you try to play this file that has an extension of NTU8, it will download you automatically a file like this. I'm going to save it, and I'm going to open it. I'm going to open this file. This file has this. In my case, I only have one quality. If we will have created more qualities, I will have more lines. But as I mentioned before, we have created this channel in minutes, and you don't have to need any programming experience, because I haven't implemented an if conditional, switch, for loops, or tell you to learn some crazy new language. You have done this only by following a wizard. Yes. In minutes, we have created a live stream. And this is a clear example of what Netflix does. If you are a fan like me, you go to Netflix when there is a pay-per-view, you watch the pay-per-view, and in some minutes, the video is recorded and you can play it on demand. So that allows you with media package. Media package has a very interesting feature that is called harvest job. When your live streaming ends with harvest job, you can capture that live event, you can transform it on an on-demand video, and it only can take 2 to 20 minutes. It depends of the quality and the duration of your or your event. But media package allows you this. And also media package allows you to use like a key to cipher your signal, because if you copy this URL, you create a website, you can put this URL and the video will play it. And you will not spend any money because all the CDN and all the costs will be in my account. In package, you can put this key to cipher your signal, and only the sites or only the backend that has your key will be able to play it, not in the others. There are examples to use Media Live with Media Package. You can use Media Live with S3 if you want to spend less. You can do it. Then you can, for example, create a fast channel. Fast channel is a channel where you only use VOD, like Pluto or Tubi. You can do it like this. Live mixing. Live mixing. I don't know what is live mixing. If you can define me what is live mixing, I can try to answer that. If you want to do a proof of contents, a concept, you can use Media Live with S3. It's it's cheaper than Media Package and Media Live, but with Media Package, you have other great alternatives. You can record your live events, you can protect your signal, you can add subtitles, and you can add a lot of crazy things that with S3 you can't. So it depends on your necessity. I have clients that we have used S3 with Media Live. I have others that we have used Media Package, Media Live, Media Convert, Media Tailor, and Media Connect, all the media services. So it depends. Yes, you can mix live content with VOD content, but with that you have to use other service called Media Tailor. In Media Tailor, you can create a live streaming with those, but you have to use all the media services that AWS provides you. So this is the repo. You want to follow my instructions. This is the player, and thanks a lot. Thanks a lot. If you want to follow me, this is my LinkedIn account or my GitHub account. And as I mentioned before, a very big fan of John Cena, the greatest champion of all times. Thanks a lot. As many of you saw, you can see me.
Hello, everybody. Good morning for the ones that are in America, and it's almost end of the day for the other ones that are in the other side of the world. So I'm really happy to be here. I'm excited to share with all of you. And okay, let's get started. Today we're going to talk about something about from chaos to clarity, the right stack for Gen AI on AWS. My name is Jesus Sanz. I am a cloud software architect, and I am also a serverless hero. Okay, to start discussing about the right stack for your Gen AI application, we need to understand something. And I don't know if it ever happens to you, but it does to me. Then I start wondering about, do you know why your Gen AI stack is not working at all? So before we can move forward, I think it's good to know who I am and why I think, well, why I'm talking about this topic. And basically, I started to create Gen AI applications like 1 year and a half, like everybody else when the boom of Gen AI started. I say I want to learn a little bit more about this, and I start to create an application on that. I create a virtual agent that helped you to connect with the AWS community and also to learn about AWS. That application is already in production and is running, and it's helping a lot of people around the world because it's an application that it will respond you in the language that you prefer. If you're talking in Spanish, it's going to talk in Spanish and all. But to actually get that application up and running, it's been all the journey. I made a lot of mistakes. Now I am creating Gen AI application in my daily basis, not only that application that I create for the community, but for production and clients around. Well, uh, they dream to have a Gen AI application up and running and production, and I'm the one to help them to actually can do that. Okay, but to actually get here, I made a lot of mistakes, and I'm continuous learning, like all of us in IT world, because that's our daily basis. We need to keep learning all the time. But something that I realized when I started creating Gen AI application that is different from the other kind of projects that I've been working on before is that Gen AI is changing constantly. So after 1 year and a half, I have several applications, and the one that I was mentioning before, I get to this question: why my Gen AI stack is not working as I want it to be work? Because when you see the advertisement, they say this is pretty simple. You're gonna have all the control, and you can create easily your application itself. But when you get to production, you realize that's something that is not that easy. Okay, so what happened to me? Like everybody, when the Gen AI explode, they're gonna have like several concepts up in the air, several tools names, and each day you have a new tool that you can use and explore. So that the same happens to me. In the beginning, I started to learn about agents, about then something called MCP came out, then something A2C came out, then I heard about Versal AI SDK, then I started hearing about the strands, and everybody just offer me a different kind of tooling for I can improve my Gen AI application. But how can I make the right decision about this? And some of us, they want to, like, if you are like me, you want to test it all to see what is actually the best or not. I am a builder, so I like to code and I like to actually test it out the tools before I can implement it and say, yes, this is the right path to go or not. Uh, and when I realized in several clients, what I found out is that, like, because we have so much different kind of setting of tools, sometimes we want to play it all and we try to implement it all of them together. So in some parts, you're going to have something about the strengths. In some other parts, you want to test something about Vercel because you heard there was awesome for this part and I can implement it here. Then I do want to have agents, so I create an agent. So later on, I realized that I need more than one agent. And I say, okay, we can have an agent to agent, and I implement it in there. But what's going on? You keep getting bigger and bigger and bigger each time. And you can come from this. You can go and say, okay, I have so many different tooling in here in place that I need an expert to actually support all the different tooling. And this is something that is hard to maintain in the time. And it's something that is hard that you have been an expert in every single tool that you have in your stack. So before you even get to decide which stack you need to take, you need to analyze what is the need that actually have in your business. What is the need behind your to generate application? In some clients, they want to something like just a basic agent that responds me. That give me some straight answers all the time. And in that case, you don't need Gen AI. And that's because it's on topic and it's the something that is in fashion or something like that. You need to actually implement the Gen AI. If you don't need it, don't implement it. So you need to get to know your customer, the need about the project for actually decide that this is the right path or not. In some other cases, you're gonna find out that you do need a Gen AI, and that you have more complexity that you are finding out, and then you can select the right tooling for that particular case. But not because you have like 100 tools out there, that means that you need to implement it all. Okay. So that's gonna avoid you to get in this part of the chaos, most of all because Gen AI applications are expensive and you don't want to because you want to try it all, you got a huge bill to pay at the end of the month, right? So we need to be careful about it. Don't be afraid to actually implement something, but you need to be in the right page to understand what your client actually need. What do you need in your application? And try to identify the right tooling for each different case. Okay, so we need to understand a little bit about concept for you can take that decision, and that's something that today I want to share with you, because now in my daily basis I change it several times about different projects about Gen AI, and as an architect, I need to be the one to recommend the client what kind of tooling they need to decide. So I came up with an idea about how can I take that decision wisely, and that's the one that I'm going to share with you today. For you can have like in your pocket something that will help you to go through on that decision tree and make a little bit easier that kind of decisions. Okay, so the general concept that we need to understand is, first of all, what is an agent? And probably some of you, if you've already been learning about Gen AI and all that, to say, I already know what is an agent. But it is really important to actually understand it, because when everything started, I thought that I have the right idea, but I realized now that I didn't have it completely. Okay, so an agent, it is a tool that you can use to connect with an AI model to actually help you to satisfy one task. Yeah, and that's important. Why? When I started my first application, uh, I got the concept that an agent is the one who's gonna talk with the client, and if the client gonna have like the user gonna have like 10 different questions, the agent should be capable to answer all. And I created my first agent, and I started to have several users and several different kind of requests And I just keep adding more information to that prompt for actually the agent will know what to do and where to find all that information. And what happens to me in the end is that because I told the agent to do too much stuff, it start to hallucinate and it start to messed up the concept and didn't know actually what is the right answer to the user itself. So that's why we need to be careful. An agent needs to be focused and need to know, it have to know one purpose that needs to be fulfilled by this agent. If you're gonna give a purpose to that agent, only one, they're going to do it each time better, and it's gonna be do it fine. They're going to know about I am an agent and I am expert in communities. I'm having all the information about communities, and that's my only job. I don't know any concepts about AWS. I don't know any concepts about uh, and know about certification. I don't have that knowledge because my expertise is the communities of AWS. Okay, so that's something that painfully I learned in the wrong way. I suffer a lot about that because the final user it doesn't have the answer that I expected. And when I started to look at more deep about what is the reason of that, I realized about this. The agent needs to be focused on one task, and the prompt that this agent is gonna handle should fulfill that only task and not too many, because if you have too many, it's gonna last. Okay. Okay, once we know we have an agent, now we facing a new reality in the Gen AI world. We have architecture patterns and how we can decide which kind of that architecture pattern that we need to follow or what is actually what we need. The first is agent to agent. Okay. Something that is important we need to understand about this pattern is that you're gonna have, like I mentioned, you're gonna have one agent, they're gonna have one purpose, right? So if you have it like that and you realize that your application needs to do several tasks and they need to be an expert in different topics and need to be perform different tasks in deep, you need to structure your agents in that way. So you're going to have one agent that is experted, like I said, in communities. Another one is going to be an expert in certifications. Another one is going to be an expert in articles. Another one is going to be an expert in podcasts or YouTube videos and all that kind of information. So this pattern, what it helps you is you're gonna have like one principal agent that is gonna be the controller of all of that, and they're going to receive the information, the question about the user, and if the user say, "I want to know about the certification of I don't know, Gen AI practitioner," this agent is gonna be smart enough to know how to get that information, but just to know what agent contains that information itself, and it's going to route that question to the correct agent, and the agent that is an expert in certification is going to provide that answer. Something that is important to know about in here is that this agent is going to take the decision and it's going to send or redirect the question to the right agent. That means that is a connection between one agent to another agent. Okay, not at two at the same time, but one that is going to fulfill the needs that the user is asking. Okay, and we have another pattern now, and probably you already heard it, and it's an MCP. An MCP is going to provide you a different layer. It's going to go deeper than an 8 to 8 pattern. This is more for, let's say you identify that the customer or in your application, you need to have more complex tasks to fulfill. Let's say that I want to create a travel itinerary. And for getting that, I want to have like the weather. Then I need to have like the air freight that I can take. I need to know about hotels. I need to know about I don't know, places to visit when I go to a specific place, and you have I need to create a reservation in the hotel. I need to create I need to buy the air tickets to actually can fly to the place that I want to go, and all the different kind of task that your agent needs to be aware for actually can uh, provide the right answer to the user. Okay, so there are different tasks if you notice. So in MCP you have a controller also, like you have a to A, but in here this controller is going to be smart enough to identify not only one to redirect the question, but actually to understand the decision making behind it, and can send different kind of requests to a different agent that you have. So in the example that I was describing before, you're going to have like maybe 3 or 4 different agents that are expert in different topics, but I need to go and create the reservation, go and create and buy the tickets, or and the other one I need to provide places to go visit when you have it in there. This one is smart enough to actually can call different agents at the same time, and they can process different requests, wait for the answer, and reply to the client itself with all the information that the user is asking for. Something that is more that is really good about this parent is that you can actually manage the security behind it. So let's say one MCP needs a different, I use a third-party agent in here, or another MCP in there, and I need to have different security layer. I can actually configure that and tell it that to the main controller, and he will know when to apply or not different kind of security with the communication and with the task, the specific task that they need. So this is really much deep understanding. You can actually have the control about how that decision making is happening in behind. So that is really good. But again, you need to analyze the use case of your client to see if you really need this, and another banner, or may you may need something really simple, or even you can identify you don't need Gen AI in your solution. That is an answer. That's a valid answer, and not because the word that we have all in all our session is Gen AI needs to be the answer for all the projects that you have in your company. So that is something that's important to know. Okay, so with that said, what is the difference between A to C, agent to agent, and MCP? I have this table in here because that's the one that I use to try to identify when I need to apply one or another pattern. That is something that I actually use in my daily basis. So that's why I wanted to share it with all of you. So I have a little definition about what is the pattern difference that I already tell in the previous slide. The other one is the communication. In the A to A, you have like peer-to-peer, one agent at a time, and in the other one, you have a controller. You can have different. He distributes the messages and coordinate the agent roles. You can have a different role for each agent that you have, and it's gonna know exactly what to agent to go directly. So in agent to agent, it works well with scalability with a few agents. That means that if you have like, let's say, I don't know, 10 agents, you can go good with this approach, and you don't have any problem. But what's gonna happen when you have like, I don't know, I need to have like 50 agents to perform the different tasks that the user may ask. Do you remember that I mentioned in the beginning when you have one agent and you have like a huge prompt and it's starting to hallucinate and all that? That is gonna happen in here. If you're gonna have like a lot of agents behind it, uh, you need to keep in mind that you don't have to grow so much, because if you do it, you can start to have that that kind of problems. You may have face sometimes that it's going to pick the wrong agent in some cases. So that is an indicator that you grow too much and you need to move forward. What is the next step? If you start to having those kind of issues, you need to go to an incident approach, and you need to have more control of it, and you need to rewrite your prompts to actually ensure that the agent that is going to be triggered is the right one. Okay. For flexibility, it is really high. The agents dynamically decide which other agents invoke. You don't have to do it manually itself. With the information that the user is going to provide, you're going to know which exactly the agent that needs to be invoked. And with MCP, you lost that flexibility, because in the A2A pattern, you have an agent that actually make that decision for you. In MCP, you need to define what is the flow that is going to follow, and you need to define the roles that each agent is going to have in that flow, right? The typical use, this seems where agents have highly autonomy, so they can resolve the problem themselves, the task, and how they can communicate between one another. And the MCP is for large multiple agents. That means that if you only gonna have a chatbot that is gonna only answer really question about one topic, maybe this is not the right approach for you, and you're gonna have more time. You're gonna spend more time building it than actually to deliver value to your customer. If you go make like a different approach and something more simpler. Okay. Examples, when you can find agent to agent in AWS. If you heard about the multi-agents in Bedrock, behind that, you're going to have an agent to agent strategy in place. You're going to have one agent that is the controller and going to call the other agents, and you just define the prompts between them. Okay. And with MCP, you can have a custom implementation using event reach or step function to define your workflow itself. And you can use it as the control plane in your MCP definition. Okay. The design complexity, the agent to agents is medium. It requires some protocols between the agents. The tricky part in here is you can define the right prompt with each other that I can communicate in the proper way, and some parameters that you need to define. But with MCP, you're gonna have a high complexity because it requires roles, the controller, decentralized flows that you need to follow, and all that. Okay. Okay, and I was mentioning something else. That is the design pattern that you're gonna follow, but now we're gonna face another question. What is the SDKs or the development tools that you can use for these kind of questions? I already mentioned some of them in the previous slide about Enbridge, about the step function that you can do it in MCP. But when you think about coding, you can find, at least I tried these two, and it's been really helping me when you face a decision about the client don't want to have only one model. They can decide, I want to use in some cases Claude, I want to use Bedrock, or I want to use in a different approach. I want to have I use Cloud Sonnet for in some cases. I use Haiku for another one, because depend about the complexity that that the agent is going to resolve, you can select the right model for each different one. So that's why this tool become handy. I've been using the Vercel AI SDK, and in here, if you are a front-end developer, you're gonna love this because it is a TypeScript and it's really easy to implement. And something that is really good about this is that it's focused in the UX UI experience. So you have the answer divided by streams. So you're gonna have like a real feedback about what the model is thinking of what the tooling that is being calling, even before you get the answer, and you can show that to the user in the same way as you do it when you use it Cloud in your navigator or when you use it ChatGPT, for example. So that is really cool, and it's something that I like about it one. Uh, and the other tool that I've been using now is Strand Agents. In here, we have an easy integration about how you can configure an agent, and this could be the one that is the controller itself of one when the user gets sent the message itself, and it's going to decide which tool it need to go. When you can use MCP as a tool in here, so that's pretty cool. Uh, I did find some like challenge when I implemented because the library is a little bit big. And for example, when I use the strands and I deploy it in Lambda, I need to contourize that Lambda. So that's something that I found out when I was implemented it. And the other thing is that it also managed something related with like the streaming like Vercel, but like Vercel is created by a company that is uh, full front end and all that. It is easy to implement it in Vercel. But the Strands is gonna have something that is really cool that it helps you to handle the long time memory in your agents. So with Vercel, you can add a new tool for having that in place, and you need to go a little bit deeper if you want to. But Strands have something that is simplified that implementation. So that is something that I really like about it. Okay, and I have like a table, and you can see the difference between it and which you can pick it. The meme approach, if you already have the TypeScript knowledge and all that, for sure you're gonna love Vercel, because you're gonna have all the streaming response, and the integration with the front end is really easy to make. So this is pretty cool about Vercel. But if you're not a front end developer and you need more complexity on your end, you can go with Strands. In Strands, you're gonna use Python in here, uh, and you can define the orchestration of the agents, the tooling, the memory. That is really important. So that's pretty cool in Strands. The guidance is more oriented to conversational UA development, like React, Next.js, and all that. And this strand is focused in your backend. The agent logic design, the planning, the reasoning, and all that is designed for more complex work. Okay. The integration with models, both of them are multi-providers, so that means you can use it with Bedrock, OpenAI, Anthropic, Cohere, whatever the provider that you want. And is in both of it are really native support for LLMs and custom tools. They can use custom tools in any of these ones. So it pretty much depends about what is the one you preferred about the language. And if you're gonna need to more complexity, I always go with the strands in that case. Okay, the state management in Vercel is handle a basic state, and then do it based on the session of the chat, and hooks and endpoints that you can have implemented in here. And with the strands, the nice things about Strand is that includes long-term memory and advanced context across all the calls. So that means when you go into much deeper in the conversation and you want to the user wants to remember something that tells, like, I don't know, months ago regarding to their dog, this agent with this tooling you will be able to actually can go and find that conversation and answer based on that reply that you did it a month ago. So this is really good. The streaming is native for both of it, but is in the strands is not optimized for the front end. So you need to work a little bit more in your front end to actually can have the streaming part. Um, everyone in the tooling calling, you have token by token response and streaming. That is idea for UX in Vercel. And for Strand, you have an integrated and native with support for tooling. That means that you can call external APIs, function, MCPs, and all that. Okay. Easy to use for developers, yes. For Strands, a little bit complex. The ones that you're going to have, if you're using Lambda, about you need to contextualize your function. That's something that you need to keep in mind in here, and you need to be aware in that when you are creating your deployment strategy. Okay. Ideal scenarios is like Vercel is like chat-like application, conversational assistance, and attractive UI. If you want to have something simple, quicker to implement, Vercel is the right path to go. And if you're gonna have multi-agent system, complex chatbot, and advanced logic, Strands is the best way to actually achieve that. Both of them are open source, and Strands is going to be stronger. You have documentation in there that you can follow. And with Vercel, you have a large web community that is happy to help if you have any questions regarding to this, okay? Okay, so based on that, I create a simple decision tree for all the concepts that we just go, and now that we know all what the difference between the patterns and the difference between the tooling, you're gonna have this one. And when you are creating your application, basically you can follow this decision tree and you can go forward. So it's not gonna take a lot of time to actually do it. So what is the first thing that I answer to myself when I am designing this kind of application? So does your application require a single agent or multiple agents? If it does require a single agent, that means that you require an advanced, you can ask yourself if you require an advanced orchestration with memory tools or not. Not in all cases, you're gonna need it. If you do, you can use Amazon Bedrock agents. You already have the native orchestration and it's just one agent that's going to perform just one task. So you can do it simply. In here, you don't have complexity code to develop and you can configure really quickly. The other one, no, I don't require a memory or any orchestration in place. So you can use something lightweight like Vercel, like what was mentioned before, and you can have a simple chat when you can interact with your agent easily to implement in really, really like in minutes, you're gonna have your first agent up and running, okay? Another thing that you can ask yourself is, do you want control over the agent internal logic? In some cases, you don't want to know what is going on inside it. You don't need it to know. But in other cases, you do. And if you want to have why the decision was making and all that kind of details, and you can define your workflow, then you consider strengths. Because in there, you actually have all the different orchestration and you know why it picks it up one from another. And if you don't need it, that you can have like a managed orchestration with Bedrock agents. With multi-agents, you can use that in here, or you can even use it with Vercel in that case, okay? That is a simple agent. In here, you already know that you're going to need GenAI, you needed to use it. There is another case when you identify that you actually don't need it. Maybe you can gonna have one chat that is going to reply, that you're going to define a specific workflow each time, and you can have the same answer all over again. In that case, you don't need GenAI, and you can make the decision that in this project you don't need it because it's not required to actually can achieve that. For sure, it's going to be cheaper. Okay. The other way to go is that your application requires more than an agent because it's going to make a lot of different tasking, and for sure you need more one agent. So in that case, you need to select which architecture pattern you're going to follow. Okay. We already discussed the advantages to use agent to agent, and what is the case when you need to know an NCP in place. Of course, you have a different complexity between them, but believe me, if you are in the designing phase of that part, this decision is really important. It's going to save you a lot of time. It's going to save you a lot of headache to actually identify the right one and make the right decision to go forward. Okay. After you decide what pattern you're going to follow, you need to select what development tools you're going to use. And if you have an interactive front end, you can go to Vercel. Even if you're going to use MCP, you can use Vercel because you can do it in a way, like a tool in itself. So you're safe with that. And you're going to focus in the interaction with your client itself. And if you are an expert in TypeScript, you're going to be happy with it one. But if you, even with that case, you identify you have more complex logic in your backend, the right answer always going to be go with strengths. You're going to have more control and about the decision making, and you're going to have for sure, you're going to save time implementing the memory and the long-time memory in place. Okay. Okay, so pretty much if you have this one in your daily basis, this decision tree, and you have it like printed out and put it in your wall in your office or something, it's really gonna help you to make this kind of decision. It's not gonna take you like forever to identify which is the one you need to select, because this is a decision that you need to make in each different project. And for sure, once you identify what is the pros and cons, you're going to make the decision a little more faster with the time. Okay. Do you want to learn about how to implement each one? You can go to this QR code. I have examples about how can you implement Vercel, how you're going to implement Strand, how you can make this kind of decision. I write a lot about serverless technology, so you can follow my content, and for sure you're going to find something interesting in there. Okay. And I don't want to finish my session without mention this all over again, and I'm gonna send you this quote that is not about the choosing the best one, but the most suitable one that you need. Sometimes the right decision is not go with Gen AI. And other times it is go with Gen AI, but not all the different aspects of Gen AI in this wide world that we have. You can minimize what your needs of your client that is really require, and make the decision based on that. Always, it's gonna save you time. It's gonna save you headache. It's gonna save you money. So that's important, because Gen AI is not cheap, right? So yes, we need to fail faster. But we need to be careful about the right path that we're going to follow. And this decision making and all this concept is going to help you to go deep in Gen AI without fear, and to feel a little bit more comfortable about the path that we all facing right now, because it's something new. Tomorrow we're gonna have a lot of tooling different or more tooling that we have right now, and that is fine. You need to understand what is the pros and cons for each one of them, for you can make it easy to take that to make that um, decision. Okay. So with that, thank you for all of you. My name again is Hazel Science. My LinkedIn is Hazel Science. You can follow my content in there, and that's my website that I live in here. And I'm really happy to share a little bit of my experience with Gen AI application. And for everybody that is in America, Have a great day. And for all of the rest of the world, have a nice evening. Bye-bye.
All right. Hope I'm audible right now. So this is the most anticipated time you are all waiting for, and I will walk you through the registration process now. So as you can see on our AWS Community the global page, if you scroll down, there you can see the button. Click on the button, and here the registration form will appear. There are several fields marked with red asterisks there needs to be filled in. And the most important one is builder ID. If you already have your builder ID, then the most important thing we need from you is this one, starting with @ at the beginning. For me, it's this one. If you click on the pen button, then you can see it's shown as alias for you. If you don't have your builder ID, then there is a pretty straightforward guide here. If you click on the link, and here are all the steps you can follow, and I'm pretty sure you can create your new builder ID right now. Then please double check that you put the valid email address, because this one is the one that you will get contacted by agency once you are the winner. So once you win the raffle. And then there are 6 keywords that you need to fill in. All the keywords have been presented or showed during the presentations. This is the example. It's not case sensitive, so it doesn't matter if it's upper or lowercase. This is the example. This was an awesome event. And yeah, if you click on a submit button, then you are in the raffle. So we wish you a good luck, and maybe some few words.
Yes, we wish you good luck, and in name of all of the crew and all of the user groups and communities, we would like to thank you for attending today, being with us, and making this event awesome.
Thank you.
Thank you.
Thank you, guys.